turn on live captions. Now, as I was saying when I started the bias, there's always, very rare do you do research and not form some opinion of what you're doing. Now, that's okay as long as you don't let it interfere with what you are doing. Now, that means your math, it means your surveys, it means your research, it means everything that you do with the research project. You have to be careful of bias. Does anybody know what happens when you put sugar in a gas tank?
It don't run.
It will ruin the engine. Okay? The reason I tell you that is bias can be the sugar in your research gas tank. So, and if you don't think people can see it, they can. And it's very important whether you're doing it for a research project at Clemson University or whether you're doing it for Michelin and you're paid $125,000 a year as the director of quality assurance, or you're at Bosch and you're presenting for next year's defective tires or defective carburetors or defective injectors, and you drop the ball and the next year you're fired. Okay? So it's not something that you just worry about when you're in school. There's an old saying in life, you get out of it what you what?
Put into it.
Put into it. That's one of the most truest sayings in life. And everybody does not get a trophy. All right? If you do your work and you do it the way that you're supposed to do it, you should be rewarded. And using bias is not. Now, I'm going to go ahead and pull up my whiteboard, and I'm going to talk to you about what the different ways of bias you can have. So, hold on a second. Let me fix this. Okay, and make sure. There we go. As I started with you Monday, bias can go in two directions. Well, actually, three directions. Yeah, there's no noises when I'm not talking. When I'm quiet, there's no garble. So it must be some kind of feedback. Three directions. LAD, by mistake, or intent. What is LAD? Lazy ass disorder. Okay? That's what LAD is. Hubert suffered from many disorders when he was a teenager. One of them was LAD. Now, I would outwork anybody on the farm. Okay, that wasn't my lazy. My lazy was thinking I knew everything and I didn't have to listen in class. That kind of lazy. All right? And that happens in academia and it happens in the real world. Mistake. You give your report to somebody in graphics. You work at a nice magazine or newspaper, and you do this nice report, and you give it to a graphics guy that doesn't know mathematics, and he puts the wrong graphics up. And then intent. You work for a magazine, and you don't like your cousin just had a brand new company hit Fortune 500, and you're jealous, so you go out and you tank his company because you're jealous. Okay, those are all three reasons that you will see bias. Okay? You can also, where can you see bias? In the questions that you ask. Now, you think I'm being, a little bit, I don't know, overboard on bias? you spend, when you go and you get a master's or you get a doctorate in a certain area, you have to take a whole class, a whole semester on survey questions. I had one instructor at Clemson, and he gave us 100 questions. And throughout the semester, we had to mark those questions where there was a bias. And that was the grade for the semester. Now, a lot of you think, oh, well, that's easy. It could be as much as the placement of a comma. It could be using the word is instead of. Okay? There are a lot of things that you can put in your questions that can be or lean toward a certain way. Remember, what's the opposite of bias? Uniformity. Okay, that's the opposite. In order for your research or for any type of research, whether you're doing it for an academic project or you're doing it for your career, the opposite of bias is uniform. Right down the middle. Your research, your survey, your research can be biased. I don't even know if I spelled that right, but I'm not going to worry about it. Research. Let's say that I wrote a 10-question survey and I just give it to all white males. Is that good or bad?
Bad.
It's bad. I'm only getting a perspective in that survey, no matter how good my questions are. I'm just getting it from white males. That's not good. Okay? Not only does your questions have to be in line, you have to be diverse with where you send it. Number three, you need to make sure that you tally your research. What do you mean tally? Well, there are some people that if somebody does not respond, they will mark it down as being against something. Okay, let me rephrase that. There are actual people that if you do not respond to their survey, they will count it as you being against whatever they're doing. That's not right. No response is its own category. If you send out 50 surveys and you get 49 back, then that one response goes in not responsive. And then the biggest thing is your interpretation. How you interpret something. Can anybody give me an example of something that is biased?
The news.
Oh my, you should have said that. Hey, you're going to get me in trouble. Besides the news, can anybody give me another example? But you are correct. And I'll just go ahead and just get in trouble for saying it. The news is biased. How about the weather? Have you ever watched the Weather Channel? And there's a hurricane, and that guy in the raincoat is acting like he's about to fall down, and there's 2 or 3 kids walking barefoot behind him. You ever seen that before? Are they trying to project something that isn't true? Yes or no?
Yes. Yes.
That is bias. What else? Give me one more example.
ESPN.
What? I didn't hear that. What? It can't echo. What?
Say it for me.
ESPN.
ESPN. Yep.
They like SEC too much.
If you put a, well, I don't want to get into a discussion about this, so I'm just going to shut up. I will say that, yes, you're right. You put Ohio State against the Tampa Bay Buccaneers, and the anchors will say Ohio State is the greatest team in the world. Okay? Ohio State is one of the most overranked teams in a weak conference that there is.
Amen.
So I'm just going to say that. I'm not going to say any more. Because eventually we'll get to the all children's conference, and I'm not going to go there either. So anyway, we'll just leave that alone. All right. So now the biggest thing you got here to keep you from being biased with your research is your random sample. Now I told y'all that I needed to go over something with the random sample, and we're going to go over that right now. Okay? So I'm going to kind of backtrack into 3.1 for 1.3 for a second to help you out with your homework, okay? So this is 5.1. You can read, I'm sorry, 1.5. You can read 1.5. This is the highlights that I will test you on. Main thing is to be able to tell me what bias is, okay? All right, now, with a random sample in 1.3, and the reason I'm going over this is, did I go over the random table, and did I go over how to do it on a calculator?
No. You did not.
Okay.
He did the random table. You said a calculator.
Okay, guys, I appreciate y'all inputting, but since y'all are at the back of the room, it's echoing and I can't hear you, so say it a little bit slower. What?
I'm pretty sure we did the table, but not on the calculator.
Okay. I'll go over everything just one more time for everybody's sake. And one is names in a hat. Names in a hat. And names in a hat, I explained that to you. That's how you do a random sample. And I will test you on that. In other words, if I give you an example and say, there's 23 students in a class, and I put their names on the bulletin board and throw a dart at it, is that a random sample? Yes. If I throw a dart at a board, that's a random sample. All right, so that's the same thing as names in a hat. The other way is a table. Now, I'm not going to test you on the table, but I'm going to show you how to do a table. And the third is your TI generator. And both of these are used with big attitude numbers. So if you got 500 employees and you want to pick 5 people for a trip, you're not going to put their names in a hat, okay? So I'm going to explain to you these 2 guys right here, and I will test you. Listen to this. I will test you on this one. Capiche?
Gosh.
All right. So I'm not going to do names in a hat because y'all understand that. Table. Let me go back to 1.3. And the only reason I'm pulling up 1.3 is because I don't want to have to write the table out, even though I think we did the other day. I can't remember. And I've got 3 120s, so I can't remember what I did. So I appreciate if y'all just follow along with me, and we'll work it out together. So here is 1.3, and I'm going to go until I get to the actual, here it is. All right, I want you to write down the problem. It says, the accounting firm, I'll blow it up because I know somebody's going to say, and if you can't see it, get your butt up and walk up to the front of the room. It's real simple. It's called mechanics. If you can't see something, you get up and move to the front of the room. The accounting firm of Sinise and Associates has grown to make sure their clients are still satisfied with the services they are receiving. The company decides to send a survey out to 5 of its 30 clients. Now, you could do this with a hat, okay, but we're going to do it with the generator or the table. Okay, so the first thing we notice is numbers from 1 to 30. Okay, that's the first thing. I want to highlight that in green because that's the first thing you got to notice. What are we talking about? And then we've got to have one other thing. For a table, you've got to have, and I'm going to put this in red, you've got to have a what?
Starting point.
The starting point has to be given to you, or they tell you to just pick it. Okay, now for uniformity, the homework problems are going to give you a starting point. In this problem, they put it at the end of the problem. Here's the names of the people or the companies written beside each of them, so 1 through 30. And here is the digits, blah, blah, blah. Let me see if it says it over here. Okay, here it is. We start row 4, or column 4, row 13. There's the starting point. So write that down. Column 4, row 13. Column 4, row 13. And there is column 4, row 13. There it is right there. Right there, 0. And now I just go down until I get 5 numbers that are great, that are between 1 and 30. So 7, 26, 11, 23. I think that's it. Let's see, hold on. 7, 1, 2, 3. Well, it looks like 23, and there should be one more, 17. And that's how you use a table. Question on that. So with a table, you've got to have 2 things. And for your homework, they're going to give you those 2 things. Now, you can go in your calculator, and let's pull the calculator, get your calculators out. And here's your calculator. And I'll give everybody a second to get your calculator out. And I'm going to hit math, probability, number 8. And I'm going to type in 1, 30, and 5. And enter. Now look at my numbers and look at your numbers. I bet mine are different from yours. Are mine different than yours?
Yes, sir.
Why? Because we are doing what?
Random.
Random. Why do you do a table? The table questions are a little bit more uniform and everybody gets the same answer. That's good for a homework question. But when you do it in a calculator, each one of your answers are going to be different. Now, let's say you got a OA calculator. Everybody knows what OA calculator means, right? OA. Okay, so here is your OA calculator. Old attitude. Here's your old attitude calculator. And I'm going to hit math, probability, number 8. And I'm going to type in 30, meaning 30 names, comma, and 5 random numbers. I'll close parentheses and enter. And there are your 5 numbers. So number 13, that client gets a letter. Number 25, that client gets a letter. Number 9, that client gets a letter. Number 17, that client gets a letter. And number 28, that client gets a letter. Now, if you are doing a research project in your class and you want to get a random generator, you write down everybody in your class, write their names down, put a number, and then do this, and you just pick 5 people without having to throw darts, without having to use a hat or a fishbowl. Everybody see what this is used for now? It's actually a neat little thing to have. Question on that? Okay. So I've shown you all that, so we can move on to chapter 2 now. So let's move on to chapter 2. Right now, everybody is responsible, 1.1 to 1.5, and I will be putting a date on that because I noticed about several of y'all have not started working on homework yet. I don't know why. I don't know what you're waiting on. I know what you're waiting on. You're waiting on a date. I'm not going to give you a date, so you can forget that. Well, now I can't find my, well, I know I had the book pulled up a while ago. Where is it? There it is. So let me move to 2.1.
And there was a stack crunch question on one of the homeworks. Was that what you just showed us?
Yes.
Okay.
1.3, 7, 8, and 9, and 10. That's it. That's why I showed it to you.
Okay, thank you.
But you can send those questions, send them if you still got them. I didn't see any questions sent, so that's why I'm going over it. You're welcome. Yeah, you're welcome. Chapter 2.1. I'm not going to use the book right now. I'm just going to use my whiteboard. 2.1 is on one of the tools that we use for statistics. 2.1, and that is a frequency distribution. The reason I'm saying it funny is, you know what a frequency distribution really is? A chart / table. But they want to make it sound fancy, so hold your pinky up when you say frequency distribution. Now, there's 2 types of frequency distribution. Can anybody tell me what the 2 types are? Anybody know?
Frequency distribution, and there's relative frequency distribution.
Say again?
There's somebody there is. It's not what is in the homework. Relative frequency.
How about qualitative and quantitative?
Yep. Yeah.
Yeah, that sounds right. Yeah, man. Whatever. Yeah. So are my dogs gonna win that game? My dogs gonna win the game? Clemson against Georgia, they're gonna win.
Tigers on top, baby.
I think them dogs are gonna win.
No.
Tigers.
Tigers.
Are we competing? What are we in right now?
But I think they'll blow it like they do each year. But I think they're gonna win against Clemson. I'm sorry, Clemson.
You think it's wrong?
But you can always remember, if Clemson starts to lose, all the fans will get on social media and say it's the referee's fault.
We ain't worried about it because they're gonna win. Yeah.
They are.
Go Dogs, baby. Go Dogs.
I think them dogs gonna win. All right. So, qualitative. Here is an example of qualitative. Blondes, brunettes, redheads. 2, 4, 6. That is a frequency distribution.
Just gotta stop.
Well, that's, you know what I think sometimes? I think a long, long time ago, there was this guy that couldn't make it as a mathematician. So he decided to make his own little world of mathematics, and he called it statistics. And then he started to make up all this different stuff, where in algebra and calculus, you called it a table. But in his new world, it's got to be called something more spectacular. So he called it a frequency distribution. And he called a bar chart a histogram. And you'll see all through statistics that there's fancy names for stuff that you found out in pre-algebra and just called it something real basic. In statistics, it's called something, and you hold your pinky up when you say it. Okay? Quantitative. Does anybody know what this word stands for right here with qualitative? Category.
Category.
And qualitative frequency distributions, you have categories. So some of you wrestlers, I didn't say wrestlers, that's what they do on TV. Some of you wrestlers, some of you people that box, martial arts, what are those things divided into?
Weight classes.
Classes. So your quantitative data will be classes 15 to 19, 20 to 24, 25 to 29, 30 to 34. 2, 4, 6, 8. There is your two types of tables. Now, what can I ask you to do with a qualitative distribution, frequency distribution? I can only ask you to give me two things. What are they? One, the relative frequency. Somebody tell me what the relative frequency is.
Qualitative?
Percentage.
Thank you. Just a common attitude percentage. So you gotta hold your pinky up when you say relative frequency. And a bar chart. Now, a bar chart is not sophisticated enough, so you call it a histogram. Does anybody know the difference between a bar chart and a histogram?
Aren't the bars connected on histograms?
The histogram, the boxes touch each other. That's the difference. I didn't know what you said. If you said that, that's good. I didn't. hear you kind of overlap.
Good.
Right.
I thought you were just saying I was wrong and you said the same thing.
Okay, good. Then you are correct. Okay.
For what?
The board,
Can you move the paper up real quick, by the way? We're having,
Say again?
can you move the paper up, please?
The whiteboard.
The whiteboard, sorry.
Oh, you can't see it?
No, the bar with all the options is covering up that bottom part right there.
There, how's that?
Up a little bit more,
Like a block.
a little bit more. There you go.
That gum. Y'all must have y'all must have 2-3 menus on the bottom of your computer or something. Cause I'm that far up. Now, I'm gonna give you an example of the difference between a bar chart and a frequency distribution and a histogram. I'm gonna show you right now. Do I think it's stupid? Yes. Will I test you on it? No.
No.
Should you know it? Yes. For a standardized test.
Yes.
There's the bar chart. Just put page 65. That's the bar chart. Now, how will I test you on a bar chart? I will ask you to tell me how many is the total number of people in the classroom, and you have to get it with the bar chart. I will ask you how many people are in the actual experiment, and you have to use the bar chart. There's 12, there's 2, 1, 2, 4, 5, 2, 1, and 1. And you have to add all those up. That's the test question. One test question. Mr. Benninger, I've seen you once or twice. If you could pull your video down, thank you, thank you. I can't stand to see the ceiling. That drives me crazy. Sorry. All right. That is a bar chart. Now I'm going to show you a histogram. If I can find one. That's not one. Come on, where's the histogram? I bet they don't have one in the whole dadgum. Nope, they sure don't. Let's see if I can find one in the homework. Nope, they use nothing but bar graphs. They suck. Okay, I'll show you a histogram whenever we come to it. But a histogram is you got those 7 or 8 bars, and instead of having spaces between them, they're actually touching each other, and there is no mathematical difference between the two. It's just somebody won't sound important, I guess. I don't know. All right, we'll show you histogram in a little bit. Now, what is the relative frequency? Somebody said it a while ago. It is the percentage. So going back to the question that we got on your paper, this would be 6. There's 12 people in the group. So this would be relative frequency. 2 out of 12, 4 out of 12, and 6 out of 12. Now, please make sure you write down relative frequency as percentage. Please write that down. I'd hate for you to miss this on a test because of a stupid word like relative frequency. All right? Now, remember, relative frequency, you can write it as a fraction, you can write it as a decimal, or you can write it as a percent. What dictates what you write down? The directions, Hubert. That's right, class. The directions.
The direction.
Thank you. It's only 10 minutes late. The directions of your homework, the directions of your test, they will tell you round to the nearest hundred. That means decimal. They will tell you to round to the nearest percentage. That tells you percentage. Write as an improper fraction. That will be, or a proper fraction, that would be a fraction. Now, what can I ask you about quantitative data? I can ask you a whole lot more. Quantitative data. Now, you might want to make sure you listen to this because there's some classes that teach this and some don't. Quantitative frequency distribution. Class, head count, 15 to 19, 20 to 24, 25 to 29, 30 to 34, 2, 4, 6, 8. Now, what can you, first of all, you can do the relative frequency, which is a percentage. You can do a bar chart or a histogram, it doesn't matter. But what else can you do? Since a qualitative doesn't have numbers that mean anything as far as classes, you can actually find the midpoint. You can find the class boundaries. You can find the class width. And you can find the mean and the standard deviation.
Can you pull the paper down a little bit?
Y'all getting like that AT&T commercial. What about new customers? What about old customers? What about new customers? What about old customers?
I've seen that one. That one's hilarious.
We'll leave the AT&T commercials alone, okay? We're not going there, right? Yeah, we just leave that alone there, back row.
Yeah.
It's a quantitative frequency.
All right. So how do you find, you know, the relative frequency? Let's do that. Relative frequency is 2 over, let's see, that's what, 14, 20? That's 2 over 20, 4 over 20, 6 over 20, 8 over 20, and that should be it. And of course, the directions will dictate how you write those, as a fraction, as a percent, whatever.
Would we simplify that?
Yes, depending on the fraction. I mean, if it says fraction, then that'd be 1 over 10 and so on, 1 over 5. If it said fraction. If it said decimal, then your calculator will automatically do it no matter if you simplify or not. And if it says percentage, then once you turn it into a decimal, you just move the decimal 2 places to the right. So however you want to do it's fine with me. And this would be what, 3 over 10? And this would be what?
4 over.
2 over 5. Somebody help me out there.
Yeah.
Okay. Bar chart. I'm going to draw me a bar chart. And that's going to be 15 to 19, 20 to 24, 25 to 29, 30 to 34, and 2 and 4 and 6 and 8. So make sure you can do those 2 for both, and then we're going to move on to the midpoint. Now, I'm going to draw this on the next page, and I'm going to show you where all this information comes from. So I'll give you a couple of seconds to finish that up. So I teach at the Palmetto High School. I teach a class up there virtually. And I suggested that they use ear pods, and they wouldn't do that up there. What's these schools got against ear pods?
Well, it's a safety hazard.
Oh.
Our Chromebooks just, no, that's literally what, that's the rule. That is the rule. But no, we
I ain't heard
can't. In general, you can't.
So let me ask one more time. One person say, what's the problem?
Our Chromebooks are slower, and so we can't all be on our Chromebooks in the same room, or it would not work. No, that's.
Yeah, we are.
That's no, like.
Yeah, we are, right.
We can be on earbuds and classes after we earbuds for free. Yeah.
Okay.
They don't trust us.
They don't trust you. What the heck you gonna do? Oh, they think you're in listening to music. Is that it?
That must be it.
Heaven forbid you listen to music.
Yeah.
Whatever.
They don't want us to listen to heavy metal.
My son listens to music all the time. I just hit him upside the head with a 2x4, and he knows I'm talking to him.
Yeah. That's what's up.
I know. Call BSS.
Yes, sir.
Friday night. Me and him have cake parties on Friday night. Me and my 14-year-old son. All right. So here we go. It's a joke, okay? It's a joke. Please don't call DSS. Good. Golly. Actually, my son got on the bulldozer yesterday, so I was proud of him.
Hey.
He was playing on the bulldozer yesterday. All right, so here we go. 15 to 19, 20 to 24, 25 to 29, and 30 to 34, and 2, 4, 6, 8. All right, I'm going to get the highlighters out.
Uh-oh.
Can anybody tell me what this column is called? Besides the column on the left. It's not the column on the left. That's not what it's called. Anybody?
Is that the lower range of the clouds?
You almost got it. Yes, it's all, some people call it that, but this book, I think, or the last book, calls it lower class limit. So write that down. Lower class limit. Now, why do you need to know what it's called? Well, one, so you don't sound ignorant when you're in mixed company. And two, when we do the formulas here in just a minute, LCM or LCL means lower class limit. I'm not even going to ask what you're doing back there. I'm going to leave that alone.
I was trying to, my wrist won't stop popping. I didn't know if that was like normal.
Oh, yeah, that's the early sign of arthritis. It is. It's the early sign of arthritis.
That's what I'm doing. How about that?
And this is lower class limit in green. What is the yellow?
Higher class limit.
Or upper class limit. That's good. Upper class limit. Higher is not sophisticated. Remember the guy that made up this stuff? He wanted to sound important, so he called it upper class limit.
Yeah, I remember that.
All right, so how do you find the midpoint? Why am I starting with the midpoint? Because in calculations, the midpoint is very important. Okay? The midpoint is very important. So how do you find the midpoint? Just like you find the midpoint of anything. You take the lower class limit, you add it to the upper class limit, and divide by 2. So 15 plus 19 divided by 2 should be 17. Somebody help me out.
15 divided by 19?
That's right.
Thank you.
My bad.
Now, there's 2 ways you can find the midpoints after you find this one. One way is to calculate each midpoint. But we're not going to do it that way. We're going to do it the easy way. We're going to find the class width. And we're going to add it to that number. What is the class width? Well, you take any lower class limit and you subtract the coinciding lower class limit. Or you can do upper class limit either way. I'm going to put parentheses upper class limit and parentheses upper class limit. Now, what does coinciding mean?
Going along with.
One right after the other, right? Coinciding, you could say right one right after the other. So I'm going to take 20 and I'm going to subtract 15. Or I could take 24 and subtract 19. What's my class width? 5. Now I'm going to highlight that in a pink color because that is important, because now you can use that to finish your calculations of your midpoint. So what is 17 plus 5?
22.
22.
What is 22 plus 5?
27.
And what is 27 plus 5?
32.
And that is your midpoint. Two test questions right there. Well, actually, 3 test questions, maybe 4. There's one test question, number 1. That is relative frequency. Number 2 is a bar chart. Number 3 is the midpoints. Number 4 is the class width. And number 5 is going to be the class boundaries. Now I'm going to go to the next page and I'm going to show you how to do the class boundaries. Now there's a little thing I like to tell students before we do class boundaries. And it's a little pattern that I come up with. And I don't know if you'll see it in the book. I doubt it's even in the book, but it's something that I use and it helps students. Well, the ones that actually do the homework, it helps them. So I'm going to write it on the next page again. Class and head count. 15 to 19, 20 to 24, 25 to 29, and 30, 34, 2, 4, 6, 8. And I'm going to take a purple highlighter and I'm going to highlight where the class boundaries are. There's class boundaries. And the class boundaries, there's no math involved. It's just observation. And I tell students that if you start off with whole numbers in your frequency distribution, then you go to the 10th. If you start off with tenths in your frequency distribution, then you go to the what? The 100th. If you start off with hundredths in your frequency distribution, then you go to the what? Thousandth, and so on. Okay? So, we got whole numbers in ours. So, and the 10th that I'm going to use is 0.5. 100th, I would use 0.95. Thousandth, I would use 0.995. If it was a 10,000, I would use 0.9995. You're not going to see, in this class, you're probably just going to see tenths and whole numbers. But if you see the thousandth in your frequency distribution, then you go to the what? 10,000, which would be 0.9999. So what comes before 15? What number comes before 15?
14.99.
14, and you'd add the 0.5. Good. 14.5. Now, add your class width. What is 14.5 plus 5?
19.5.
What's 19.5 plus 5?
24.5.
And 29.5. So your class boundaries are 14.5, 19.5, 24.5, and 29.5. Now, I guarantee you there's a couple of y'all out there that's had probability, and you may not have been taught that. I don't know. Some probability classes ignore this stuff. I don't know. I don't know what you've had. Can anybody just give me a quick hand raise? Anybody remember seeing this before? Okay, so you've seen it. That's good. Now I'm going to pull up the mean and the standard deviation for a frequency distribution. Mean and standard deviation of frequency distribution. And I'd like to put formulas with it. Hold on just a second. We could use that one. Yeah. And we could use this one right here. Yeah, I like this one. So let's see. I'm going to copy that. Give me a second, guys. Let's go with the word processor. And let's put it right there. Let's do a Control V. Let's do a landscape. And there you go. So I want you to write that down. We're going to have a little fun. I do not use this one. So let me take my handy dandy whiteboard. And I'm just going to take that out right quick. If y'all don't mind. There we go. All right. So write those two down. So the mean of a frequency distribution is equal to the summation of f times x over the summation of f. Or can anybody give me the other letter for the summation of f? If you add up all the head count, what is that also called? What letter is that? N, Hubert. That's right, class.
And
So you could say N on the bottom of that, because they do on the standard deviation. And for some of you people that have had probability and statistics before, what is the relationship between the variance and the standard deviation? What do you do to one to get the other? Anybody? Okay, I'll show you. So there, I'll write it down. Variance is equal to N times the summation of f times x squared.
You have a work email.
That's somebody bitching about something. Times the summation of f times x squared over n times n minus 1. It might be those three students, they finally figured out where my handouts are. Here you go. Let me get out of this. Where's my dadgum cursor? There it is. There you go. What is the relationship between the variance and the standard deviation in probability? You should be able to tell me now.
Standard deviation is equal to the square root of variance.
Exactly. Write that down because somebody may ask you that question in the future. Like in a standardized test form. Good job, Mr. McDonough. Thank you. Appreciate that. Mr. McDonough got the COVID.
this is done.
You wait. The closer we get to election day, all y'all gonna have COVID. Oh, shut up. Bad, Hubert. Bad, Hubert.
Bad, you mean.
I don't know why I say stuff like that. It's that tick that I have to take medicine for.
Kids and jokes.
When I was in the Marine Corps, got hit over the head with a Q stick, 17 stitches. One thing you'll always learn when you go through the Marine Corps, there's always somebody bigger and there's always somebody that's got a Q stick. All right.
Houston. Yeah.
What's that?
Yeah.
No, nobody's gonna say anything. Okay. And they didn't use the small end. They used the big end, of course.
Houston.
Now, how many of you know what F is and what X is and what all that is? Y'all know that? A simple yes or no will suffice.
No.
Okay, I think I heard no, I'm not sure. Okay, F, you don't have to worry about F, because F is the frequency, that's the head count. So you just put head count right there. Head count. X is the midpoint. And that's all you need. Now, I'm going to go to a spreadsheet, and I'm going to show you this. And I'm going to go to the spreadsheet for two reasons. One reason I'm going to the spreadsheet is because it's less sloppy. I don't have to write all this stuff everywhere, okay? Another reason is it gets everything on one board for y'all so you can see it. So is everybody okay with me going to a spreadsheet? Well, I really don't care. I'm going to it anyway. So here we go.
Wow.
Yeah, I know. I can be a bastard sometimes. All right.
This guy.
Here is my spreadsheet. And I'm going to kind of blow it up since y'all are, trying to squint with your eyes. So I'm going to try to do this. I'm going to make them a little bit bigger. And a little bit. And I'm going to color the dark of the I can't talk and chew bubble gum at the same time. So give me a second. All borders. There we go. Can you see that a little bit better? And I'm going to make the background a little bit on the gray side. So maybe it'll help you out a little bit. Is that a little bit better? Can you see that a little bit better? Okay, nobody's going to talk, so that's fine. All right, so I'm going to use, let's use 20, let's see, what was my 19? 20 to 24. I'll fix this in just a second. 25 to 29 and 30 to 34 and 2, 4, 6, 8. I'm gonna make these bigger so you can see it better. Center them up a little bit. This is your lower class limit. Your upper class limit. And this is your head count. Now, I'm going to tell y'all something, and y'all don't want to hear it. But if you read the formula will tell you what to do. No sneezing in class. All right. So look at the front. Look at the first. Look at the first. You got the COVID if you sneeze. If you sneeze one more time, that means you got the COVID and you need to run out of the room real quick. All right. So how do we get in? Somebody tell me how we get in.
It's given, isn't it?
You add up every what? You add up all the what? F's, right?
Yes.
So that's N. Write that down. N is equal to 20. I'm going to highlight that green because that's something we need in the formula. So we got N. So I'm going to take my handy dandy highlighter and I'm going to highlight N. We got N. Got N. Got N. Now what do we need? We got F. So where's F? F is right here. Each one of these is F. So I'm gonna highlight those. Yellow. I wish the IT person could get that fixed. If the IT person comes back, tell them that whenever I talk, there's some garbledy feedback. It'd be nice if they could get that taken care of. All right. Here's F. 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 So what's the only thing we need, people? What's the only thing we need for our formulas?
That little, you're saying, that weird thing.
X. We don't have X. We don't have X.
That little squiggly. Wait, is that the summation symbol?
Okay, this right here. Anybody know what this means?
Sure don't.
That is your capital sigma. Write that down. Capital sigma means add up all the numbers. Capital sigma in mathematics means add up all the numbers. The actual word is summation. The actual word is summation. But we'll deal with the orange later. Right now, we need X. And what is X? The what?
The midpoint.
I'm going to go over here. Okay, some of those, that gobbledygook is not going. Okay, please don't make noises to go with the gobbledygook, please. All right, so here we go. X and equals parentheses this guy plus this guy divided by 2, and I'm going to freeze that 2. I'm going to hit alternate function F4 or alternate F4. Control. And that should be.
All right.
Check my numbers, see if that's what y'all got. Or that's what we got a while ago. What else do we need besides? What else do we need besides X? Hold on and I'll get it on there. What else do we need besides X?
Summation.
Nope, not yet. We need another variable. What is it? We need X what?
Squared.
So I'm going to make another column. And it's going to be called X squared. Now, anybody with enough teeth in their head can do some of these in their head, but I'm going to actually do it in the 17 squared and then copy it down. Go ahead and square those and write them down. Now you're ready to plug and chug into your, but we got to do we got to do 2 more things. But I'm going to let you write these down because these are the columns. And if you don't use a spreadsheet, then you just make these columns by hand. So let's find the mean. mean. Let's go back to our mean formula. What do we do to find the mean? We multiply F times what? F times X. So let's go to our F times X, and we'll make a column called F times X. F times X. And that's going to be 2 times 17.
Pardon me, interruption. Every student who has already purchased a yearbook this year will be in a drawing to win a gift card. Starting today, the first 25 people who buy a yearbook by September 17th will be put in a separate drawing to win another gift card. You can purchase your yearbook today online at Valcourt.com.
Okay, she's going to have to cut that out. All right, I'm just kidding. What do we do now to F times X? That BA orange thing, what do we do? What does that orange thing mean?
Add it all.
Add it all up. So you go back to your spreadsheet, then you add them all up. And that's your number. That's the numerator for your mean, and you divide by 20. Divided by 20. And that's your mean. So make sure you write that down, because that's how you find your mean. Now, I got about 5 minutes. I've already taken the roll. So some of y'all that's going to, go into convulsions, you only got 5 minutes. So just be chill, okay? That means to not start putting up your books and not start, that's very irritating. Please stop. All right, so now what do we need? We're going to the variance. What do we need? F times what? F times X squared, Hubert. Yes. So we need F times X squared. So we need another column right here, and we're going to call it F times X squared. F times X lift up squared. That's supposed to be, sorry about that. There we go. So F times X squared is going to be a BA number. And what do we do with that column? Add them all up. And now we've got everything we need for our formula. Let me show you. And I'm going to try to move this over where I can do everything. What is N? 20. What is the summation of F times X squared? 150, 80. Minus, what is the summation of F times X? 540, and that is squared all over 20 times what? 19. Does everybody see where I'm plugging and chugging? That's how you find the mean and the standard deviation and the variance. Now, I'm not expecting you to be able to do this the first time. I would like to ask you, those of you that have probability and statistics before, Do y'all do this?
No, sir, I've never seen that in my life.
No, sir.
Okay, well, hopefully you get used to doing it, okay? All right. Y'all have a good day. Y'all are responsible for 1.1 through 1.5 and 2.1 homework. So I will see y'all when?
Tuesday.
Tuesday. Y'all have a good weekend.
You too.
Bye-bye.
I gotta go.
No, English. Tuesday, Thursday. Hey, Jesse, unmute yourself. Did you understand that?
I tuned out like halfway through. But like I understood like some of it.
Like I did.
Hey, Jesse Abby. But I'm gonna watch his YouTube videos and try and like comprehend it. So
Athletes are now dismissed. Student drivers and athletes are now dismissed.
Anyways.
just